morning we're going to start out with 5 15-minute talks that really just scratch the surface of wind wildlife impacts. There are whole conferences on this topic, and we're just going to do a survey of what we know about some major taxonomic groups, including songbirds, sage-grouse, bats, eagles, and their habitat. So some of the big concerns that we have here in Wyoming around wind wildlife impacts and opportunities for mitigation. After each speaker, we'll have 5 minutes or so for questions from the audience, so you don't have to hold them for the end. This is going to set us up for a panel discussion on the trade-offs of wind energy that accounts for the potential impacts of wind facilities to local wildlife populations, but also the risk of a changing climate to those same and other wildlife populations. And that's what our first speaker will speak to. Embere Hall will discuss what the climate change scenarios mean for local wildlife in Wyoming. Embere holds a PhD from UW's Zoology and Physiology Department and has also served as a research director for the Conservation Research Center at Teton Science Schools. She's currently a postdoctoral researcher in the UW co-op unit. So welcome, Embere, and thank you.
Thanks, Nicole, and thanks for all of you for being here. You may be wondering why there is a climate change talk in a wind energy forum at 8 o'clock in the morning. Well, that's because, as we all know, wind energy can provide a low CO2 emissions resource on the landscape. If we're able to reduce emissions, that can slow the rate of climate change, which in theory can have some pretty big benefits for both wildlife and global biodiversity. So under that context, Nicole asked me to talk just a little bit about what we know about climate change and wildlife here in Wyoming. If I do this right. There we go. All right, so climate provides the very foundation of ecological systems. It shapes temperature, moisture levels, and resource availability, and as a result, it's a key factor in where we find animals on the landscape, how many there are, and how well those animals are likely to survive. Not surprisingly then, animals have a long evolutionary history of figuring out how to deal with climate, and they've developed these really well-timed both behavioral and habitat use strategies that allow them to maximize variation in climate. So this bird, for example, in the upper left-hand corner of your screen, has perfected the timing of egg laying such that nestlings hatch with peak food availability. Similarly, that elk calf on the lower left-hand side of your screen, he's going to learn how to move from his winter range at exactly the right time in order to maximize consumption of rich green vegetation on his way to summer range. However, recent climate change has placed some new challenges on these previously adaptive behaviors. In August of this year, the American Meteorological Society released the State of the Climate for 2016. Now you can sort of think of this as the Earth's annual physical. And unfortunately, the appointment didn't go so well. 2016 was the warmest year on record since the Society has began keeping records in 1880. And 15 of the 16 warmest years on that record have occurred since the year 2000. Now, I think given the vast landscapes and the relatively intact ecosystems that we have here in Wyoming, it's tempting to think, maybe climate change isn't happening here. Maybe it isn't a big deal. But unfortunately, concern around climate change in Wyoming is well placed. So this figure shows trends in the average January minimum temperature over the past 6 decades. Areas that show up in yellow and red indicate warming. Now there's 2 things I want you to take away from this figure. One, high elevation ecosystems in the west are particularly vulnerable, as are a lot of the sagebrush steppe ecosystems in the southern and eastern part of the state. And 2, climate change is affecting ecosystems statewide. Given the rate of change in alpine and sagebrush ecosystems, it's not surprising that there's some concern around the species that depend on these landscapes. So each of the species that you see pictured here is considered a species of greatest conservation need in Wyoming, either in whole or in part because of concerns around climate change. So this wolverine, for example, requires sufficient snowpack in order to rear its young in the spring, while this moose needs access to sufficiently cool microclimates in order to survive the hot summer. Now, we're already starting to see some manifestations of changing climate dynamics on the landscape. Warmer temperatures, for example, have been linked to mountain pine beetle outbreaks across the state, as you see in the upper left-hand corner of your screen. And warming temperatures have also been associated with increased frequency of severe fires. Now, I want to be careful here and say that climate change isn't solely responsible for pine beetle outbreaks or increases in severe fires. Climate change acts synergistically with other stressors on the landscape. So 100 years of fire suppression certainly has also influenced mountain pine beetle outbreaks and the frequency of severe fires. All of this sounds a little bleak, right? Well, I want to emphasize that the news about climate change isn't all bad. Much like 12-time NBA All-Star Bill Russell and pretty much anyone who played against him, there will be winners and losers. Now, in the context of a basketball tournament of wildlife species, I probably wouldn't bet on the bullfrog. But in the case of climate change, perhaps we should. Bullfrogs do well in warm water. They're expected to increase in distributions as climate change manifests. While lynx, on the other hand, that require deep snow cover to secure food, don't share that same rosy outlook. Climate change winners can expect range expansion, population growth, and reduced competition, while climate change losers are looking at population declines, extirpation, and increased risk of extinction. So given these species and habitat-specific responses to climate change, coupled with some limited budget availability, a lot of resource agencies have moved towards vulnerability assessments as a way to understand which species are going to be winners and which are going to be losers in the context of climate change. So these vulnerability assessments are sort of rested on three things. I'm going to step through these briefly. So one is sensitivity. That's the intrinsic sensitivity of a species. Think physiological tolerances. Think the ability to deal with different temperature ranges. If you've got a narrow physiological tolerance, you might have high sensitivity. The second is exposure. That's the degree of regional climatic change that you either have experienced already or you might experience in the future. And the last is adaptive capacity. And this is the ability of a species to cope with or deal with change. So if we think about habitats for a minute, let's look at sagebrush as an example. So sagebrush plants require a pretty good amount of moisture in order to establish and to produce. So much so that in dry years, we can see as much as a 900% reduction in production. So given that sensitivity, coupled with the exposure that I showed you a few slides ago, nearly 80% of the sagebrush habitat in Wyoming is considered moderately or highly vulnerable to climate change. Now I want to come back to these vulnerability estimates for just a second and point out to you that they're not perfect. And I'm not doing this to throw stones at one of the tools that we use to understand wildlife-climate relationships. I'm doing it to tell you that we're still learning. We're still figuring out how to quantify species responses to this relatively new stressor. So sensitivity and exposure we can understand relatively quickly and relatively accurately for most species. But adaptive capacity is a whole new frontier. That's understanding how species can respond to these new dynamics and their ability to cope with change. I'm going to step through just a quick example to give you a sense of how adaptive capacity can influence our perceptions of vulnerability. So the American pika offers a really good species for trying to understand the relationship between adaptive capacity and vulnerability. We know that they're sensitive to warm temperatures. A few hours of exposure to temperatures above about 25 C can be lethal if they're unable to behaviorally thermoregulate. We also know that they've experienced a pretty good deal of exposure. Over the past 50 years, the temperature across their range has warmed by about 4 degrees. But what about this idea of adaptive capacity? Well, pikas are pretty interesting because we thought we knew their story. There was this article that came out in the early 2000s and it said pikas, other climate-sensitive species, they're going to seek out these cool refuges and they're just going to march their way up the top of the mountain in order to find these cool environments. They're going to get to the top and they're going to be out of luck because the climate's going to get too warm. So no more pikas. That's what we thought we knew in the early 2000s, and what happened in response to that was a whole lot of research, some petitions to list the species under the Endangered Species Act. And in that process, what we found is, yeah, absolutely. In some places, pikas are showing these upslope range retractions that we expected, and they're concerning. But in other places, we're not seeing those same responses. And a lot of that has to do with the adaptive capacity or the ability of individuals and populations to do different things, to eat different foods, to eat at different times of the day. And that's providing the species with a lot more resilience than we initially thought. Now, I want to be careful here because when we think about things like vulnerability assessment and adaptive capacity, I don't want you to walk away thinking species can adapt, we're going to be fine, we don't need to worry about wildlife and climate change. That's not true. What we do know is that adaptive capacity is a whole new frontier for climate ecology. There are limits to it, but it may also provide species with a way to deal with some of these rapid changes on the landscape. Now, I spent the bulk of this talk talking about observed trends and wildlife responses to climate change here in Wyoming. I want to spend my last few minutes talking about observed global trends, associated emission standards, and how renewable energy may fit into that picture. So this figure is showing the observed trend in global temperature over the past 160 years. There's a couple things that I want you to notice. The first is that temperature has been increasing pretty consistently over the past several decades. And the second thing is that increase is happening at a pretty fast rate. These increases have been pretty clearly linked to a lot of detrimental global ecological effects, including an increased risk of extinction for a lot of species. So those observed trends that I showed you are predicted to continue. Depending on the emission scenario that you look at, we're probably positioned for anywhere from about 2 degrees to 6 degrees of warming relative to pre-industrial standards. And that's what I'm showing you here in this figure. So on the x-axis, that's that horizontal axis. On the x-axis, we have time, so the year 2000 up to 2100. And the y-axis, that vertical axis, we have the amount of change relative to pre-industrial times. Now, I mentioned that the direction that we take for warming depends on the emission scenario, and I'll step through that here in just a minute, but I want to draw your attention to the fact that there's several countries that have signed on to international agreements to take steps to try to keep warming at or below 2 degrees C by 2100. 2 degrees sounds like a small number, right? It's not a small number and it's not arbitrary. To provide some context for this, for some of these international agreements, a lot of small island nations have actually argued for 1.5 degrees because at 2 degrees, sea level will rise at such a rate as to have inundated their countries and they will no longer exist. So this 2 degree target is a pretty big deal for a lot of countries. Now, I mentioned those emission scenarios. I want to walk through these just a little bit because I think we hear a lot about them and we don't always know what they mean or what they are. So here on the x-axis, again, that horizontal axis, we have time from 1950 up to 2100, and on the y-axis, we have annual emissions of CO2. So that black line that you see, that represents historical emissions, basically where we've been since 1950 up to more or less where we are today. And then those 4 lines that fan out from there, those each represent projected CO2 emissions under different climate change scenarios. That red line denotes what we call a high magnitude warming scenario. It ought to just be called business as usual because this is the track that we're on. But there are some other options, and I want to point your attention, if I can use my pointer, to these lines here, this light blue line and this dark blue line. These are alternative scenarios that are hinged on some pretty serious mitigation efforts. One of the efforts that has really been put forward through the Intergovernmental Panel on Climate Change as a way to mitigate some of this warming is by upscaling or basically increasing our reliance on low carbon producing energy. And of course, wind energy is one of those primary tools. If we want to try to meet keep our warming within 3 degrees Celsius, it's this light blue line here, we're looking at a 180% increase in our use of low carbon energy by 2050. If we decide that we want to move towards that 2-degree target, the one that's in a lot of those international agreements, that necessitates an increase in our use or reliance of low carbon energy by about 275 to 310% by 2050. 2050 sounds like a long time from now. It's not. It's 33 years from now. It's within my lifetime, and it's within most of your lifetimes as well. So I want to point out that we're at a really unique time in history. So we're sitting here at 2017, we're about here on this figure. We're certainly on a trajectory for that high emission scenario, that orange line. We're on that trajectory, but that doesn't have to be our path forward. And we're in a really unique place because we get to decide what path we want to be on and what we want Wyoming to look like. If we're okay with a 4 to 6 degree warming scenario, then we don't need to change anything. If, however, we want to reduce emissions, we have those opportunities. But those aren't decisions that science gets to make. Those are decisions that you get to make, and the public gets to make, and stakeholders get to make, hopefully informed by the best available science that we can give you. So with that, just a few final thoughts. Climate change is happening in Wyoming whether we like it or not. It affects nearly all wildlife species, and it's a new problem that requires some new thinking, and that includes things like adaptive management, new collaborations, and figuring out how to deal with a level of certainty that we may not be entirely comfortable with. If we can do this, we may be able to find a way forward that moderates exposure and promotes resilience among some of our most threatened species. With that, I'll take questions.
I just want to thank you for having the courage to talk about climate change in this day and age.
Thanks, Hunter. Talking about climate change in this state and in this country has become a very difficult subject, and it's wonderful that you're willing to take it on and take it on so directly. And thanks for doing that.
Thank you. Other questions? Yeah.
You're telling us now we can control temperature on Earth?
I'm saying we have a shot at deciding what path we're on.
That was excellent. Ember, could you comment a little bit on at what point, kind of in the time scale, the feedback loops kick in terms of what has been referred to as kind of the tipping point?
Yeah, that's a good question, Millward. So I should say I'm not an atmospheric scientist, so my answer is going to be a little hand-wavy because I don't know the exact tipping point. But for those who aren't familiar, what Millward's referencing is based on our current understanding of climatological cycles, there are sort of these tipping points or temperature thresholds beyond which we may start to see sort of irreversible or irrevocable changes. And one of those is sort of the ocean and conveyor belt. So that the way the temperature moves around water in the ocean is considered one of these conveyor belts in terms of shifting heat around the globe. At some point, you think about physics, if the temperature gradient changes, we can shift how that water is moving and then how those temperatures are moving. I don't know the exact temperature that happens yet, and I think most geographers even would tell you that we're not super sure where that's at. I can't give you a better answer than that. Sorry, Millward.
Yeah, I also very much appreciate this. I thought that was an excellent summary of the situation. Question for you though. All of our discussion about low carbon energy migrates back to solar, wind. There's a little bit of discussion about tidal and things like that. What about nuclear? And what I've remarked to some people, you can go into Virginia and buy a submarine engine that will generate twice the energy of, I don't know, 40,000 acre wind farm. And we don't seem to be seriously pursuing this option, even though you can argue that if we were to reform our regulatory structure a bit, we could take care of this carbon problem pretty quickly.
Certainly, and that's a good point. So I'm saying a lot of what I'm not. I am a climate change ecologist. I'm not an energy expert per se. But I will say that you bring up a really good perspective, and I think a lot of that comes back to the dialogue that we have around carbon emissions and how important that becomes to us. My sense is that nuclear power has been somewhat downplayed because of the associated or perceived risks. Whether or not that's true, whether or not we want to invest in the technologies to make that a safer fuel source is certainly a public discussion. But yeah, based on my very limited understanding of it, there's certainly a future there for it if, as a public, that's the direction we want to go.
Thank you. Nice presentation. Could you talk a little bit about what federal and state wildlife agencies, and state in particular, are trying to do to deal with these three types of categories of sensitivity to adaptive capacity?
Sure, I can certainly speak to what's going on in Wyoming. That's what I'm most familiar with. So the topic of climate change in Wyoming can be somewhat challenging, and I will applaud the Game and Fish Department, and particularly the division that deals with non-game species. In the last probably 5 to 7 years, they've really started thinking critically about climate change and the effects of climate change on these really sensitive species. So we're not to the point of doing sort of wholesale assessments of what's going on with all of our species, but we are making some targeted efforts towards trying to understand the degree of vulnerability to those really sensitive species. By really sensitive, I mean the species of greatest conservation need. There are 131 of those in Wyoming. About 35%, according to the state's documents, about 35% are considered vulnerable to climate change. Of particular note, 75%, so six of the 8 of our amphibian species are considered highly vulnerable to climate change. And I think the state is really starting to think about how we're going to address this. One of the challenges for climate change in terms of state action is that it's a really big problem, right? So it sort of challenges these maybe more conventional management ideas that we have, and that, you know, it's not like over-harvest. We can't reduce the number of tags and then increase the number of deer in a particular hunt area. So it's not that straightforward. So I think the agency is sussing out new solutions, and they're doing that in a way that I think is starting to be mindful of climate change.
And we've got time for one last question.
Again, thank you for your presentation. My daughter-in-law happens to have undergraduate work here in wildlife biology, and she's now at the Bird Conservancy of the Rockies down in Fort Collins. But what they're looking at a lot is bird populations, obviously, and I was wondering if you've done projections on wildlife and bird populations due to climate change in your research. Thank you.
Sure. So with my work directly, I'm actually just starting a project where we're looking at the vulnerability of sagebrush birds, arid land birds, specifically to warming temperatures. So Wyoming is unique in that we have, I think I'll get this right, we have all of the sagebrush obligate songbirds that exist in North America. We have them here. What we're starting to see, though, is that sort of commensurate with energy development, climate change is starting to have an effect on their population. So specifically what I'm starting to look at is taking a whole bunch of data going back about 15 years and looking at differences in things like demographic rates. So that's how many young are being produced, the likelihood that those young will survive, sort of population level stuff. Looking at the relationship between that and temperature change and how that synergistically acts with other stressors on the landscape, like energy development, for example. Thank you.